Assalamualaikum and hi. In this video, we will talk about application of metallic bonding in real life. Now, let me introduce my group members. My name is Muhammad Faris bin Zamri. Next, we have Imi Danish bin Muhammad Ilmi. Then we have Muhammad Anaki Korin bin Muhammad Yusri. Last but not least, we have Nur Danish Zikri bin Muhammad Faizal. Now, let's take a look at the objective. First is to explain the concept of metallic bonding. Second is to relate the electron C model to metal properties. Third is to apply band theory to electrical conductivity. And last but not least is to discuss real-life applications of metal and semiconductors. Let's begin with the introduction. Metallic bonds can be defined as force that holds atoms together in a metallic substance. Why is metallic bonding is important in everyday life? Due to metallic bonding, metals are able to conduct electricity, conduct heat, be strong and be malleable and ductile. Metallic bondings play a crucial role in our daily lives. Because metals can conduct electricity, they are used in electrical wires and electronic devices. Their ability to conduct heat makes them suitable for cookware and industrial machinery. The strength of metals allows them to be used in buildings, bridges, and vehicles. Malleability and ductility enable metals to be shaped into thin sheets and wires, which are essential in manufacturing. Metallic bonding is the attraction between positive metal ions and a sea of delocalized electrons that are free to move throughout the metal structure. This type of bonding gives metals several unique properties. First, electrical conductivity. Because the electrons are delocalized, they can move freely when a voltage is applied, allowing metals to conduct electricity efficiently. Second, malleability and ductility. Metals can be hammered into thin sheets and stretched into wires. This is because the metallic bond is non-directional, so the layers of metal ions can slide past each other while still being held together by the sea of electrons. Third, thermal conductivity. Metals are good conductors of heat because the free-moving electrons can quickly transfer thermal energy throughout the metal. In conclusion, the sea of delocalized electrons in metallic bonding explain why metals are electrically conductive, malleable, ductile, and good conductors of heat.
Assalamualaikum warahmatullahi wabarakatuh. So, first thing first, we're going to talk about the electron C model and properties of metal. Metals consist of positive metals ions surrounded by a sea of delocalized valence electrons. These valence electrons are not fixed to one atom and can move freely. The electron C act as a glue, holding the metal ion together through electrostatic attraction. The sea of electron can exhibit properties on the metals. Firstly, malleability. Most pure metals are malleable, which means that they can be bent or hammered into place. Layers of metal ions can slide over each other without breaking bonds. Like for example, gold. Gold outer electrons are free moving, making the gold itself soft. Therefore, it can be easily malleable and shaped into any place. Next is conduction. Metals are good conductors of electricity and heat. The delocalized electrons are free to move and pass on the electrical charge and thermal energy. For example, different types of metal have a differing electrical conductivity. Like we can see here, silver and copper have a high electrical conductivity, and we use it for something like electrical wires. The next properties of metals are melting and boiling points. Metals have high melting and boiling points. This is because the metallic bonding in giant metallic structures is very strong. The strong electrostatic force between the positive ions and delocalized electrons requires a high amount of energy to overcome. And finally, lustrous appearance. Most metals are lustrous or shiny. This is because there are delocalized electrons on the surface of a metal. Moving on to the next section, band theory of metals. It's a theoretical model describing the states of electrons in solid materials that can have values of energy only within certain specific ranges. It essentially talks about the conductivity of a material. There are some key concepts in band theory of metals. which is the first valence band. Energy levels containing valence electrons is lower MO occupied by only valence electrons. Conduction band, energy levels where electrons are free to move, is empty MOs that are higher in energy. And band gap, energy difference between valence band and conduction band. So we can see here three different types of energy band for three different materials. Firstly, insulators. Insulators have a large band gap, so the electron from its valence band cannot move on to the conduction band, making it cannot conduct any electricity whatsoever. Secondly, semiconductors. The large band is significantly smaller than the insulators, so the electron can move on to the conduction band, but it's not as efficient as the conductor. And finally, conductors have no band gap at all, making it an excellent conductor. In metals, the valence band overlaps with conduction band. Electrons can move freely between bands without extra energy expended. This makes metal excellent conductors of electricity. And some example of real-life application of band theory of metals. Firstly, power transmission lines, efficient flow of electricity over long distances. Secondly, electronic circuits. Metals provide low resistance pathway for current. And finally, electrical appliances depend on metal conductors to function. For example, light emitting diode or LEDs.
Hi, my name is Danish, and for my part, I'll be presenting to you guys about the comparison between conductors, semiconductors, and insulators. So, what is conductors? Conductors is a material that allows electricity to flow easily. So, the characteristics behind conductors is it has a valence band overlaps with conduction band. So, because of that, it has no band gap, which makes it an efficient heat transfer, malleability, and ductility. So, few examples for conductors is copper, aluminum, and silver. So, one factors that could affect the conductivity of a material is the temperature. So, as the temperature increases, atoms start vibrating heavily, which leads to collision of electrons. Because of the collision, it causes a loss of energy, so it will lead to drop in current flow, which is bad thing about conductors. Next is semiconductors. So, semiconductors is materials with moderate conductivity. The characteristics for semiconductors is it has a small band gap where the conductivity increases with doping. So doping is an addition of impurities where it is also temperature and light sensitive. So a few examples of semiconductors is silicon and germanium. So it has two factors that could affect the semiconductor's activity, such as temperature and doping. So with temperature, conduction increases with temperature. And for doping, the addition of impurities could dramatically increases charge carriers. So because of the charge carriers is being increased, the conductivity is also being boosted, where it enables electronic devices creating negative type and positive type. And finally, we have insulators. So insulators is a materials that do not conduct electricity very well. Because of this, it has a very large band gap, which requires much more energy to deliver from valence band to conduction band. And the electrons in insulators remain tightly bound, thus make it has no free electrons waving around it, and it has dielectric strength, which is storing energy capabilities. Few examples for insulators is glass, rubber, and plastic. It has two factors that could affect insulators, such as temperature and moisture. So temperature has little to no increase in conductivity in insulators, meanwhile moisture causes water absorption, creates an conductive surface on insulators, which reducing the insulation resistance. And for the next part, I'll be explaining about the applications of conductors, semiconductors, and insulators in real life. So conductors could be used as a powering device, such as cable and whatnot, because it have a high abundance of free electrons that can allow electrons to move freely in a medium. Next is semiconductors. So semiconductors is mainly used as consumer gadgets. So because of this, it has an electrical conductivity that can be controlled and makes it not dangerous to use by a consumer. Finally, insulators. Insulators can be used as a cable coatings. Because of this, it is made of non-conductive materials that serves as protective barrier.
Hi, my name is Anaki, and I'm going to be explaining about doping. So, what is doping? Doping in semiconductors is the process of adding a small controlled amount of impurity atoms to a pure or intrinsic semiconductor such as silicon or germanium to increase its electrical conductivity. Pure semiconductors conduct electricity very poorly. Doping helps control how well they conduct and is essential for making electronic devices like diodes, transistors, and integrated circuits. There are two types of doping, P type and D type. P type means a positive type conductor, semiconductor. Semiconductor is doped with trivalent impurities, which are barium, aluminum, or gallium. The dopant has one less electron than silicon, and this creates a hole due to an absence of electron. Holes are the majority charges here. N-type means negative semiconductor, doped with pentavalent or 5-valent electron impurities. Most common ones are phosphorus, arsenic, and antimony. The dopant has one extra electron. This extra electron is free to move, and electrons are the majority charge in here. So you might be wondering, what is the applications of semiconductor? Well, so many semiconductors are used in diodes, transistors, integrated circuits, light emitting devices like a flashlight, solar cells, sensors and detectors, power electronics like a power bank, and medical equipments.
And finally, we reach to today's presentation's conclusion. So, metallic bonding explains the unique properties of metals. Furthermore, metallic bondings involves delocalized electrons surrounding positive metal ions, which gives the metals their strength, conductivity, and ability to be shaped without breaking. And finally, electron C model and band theory helps us understand conductivity, where these concepts are essential for modern technologies such as electronics and energy devices. So next is our reference ranging from websites to journal. And with that, we finally reach at the end of the presentation. So don't forget to like, share, and if you guys have any questions, please put it on the comments down below. Thank you and Assalamualaikum.